Let yx equal to ux sin x plus vx cos x be the solution of the differential equation y double prime plus y equal to sec x. Then ux is equal to, as u is used in this solution function, then what is the value of ux, or expression which is used for ux we have to tell about, as option A, B, C and D are given for ux. So this is a differential equation, linear differential equation of second order, and this is given by y double prime plus y equal to sec x. And the standard format of second order linear differential equation is a naught x d2y upon dx square plus a1x dy upon dx plus a2x y is equal to fx. This is right hand side, and we find particular integral if right hand side is not 0, or having the function, some function as sec x is given. So for this, suppose this is complementary function. Complementary function is c1u plus c2 v is complementary function. Then particular integral can be evaluated by as u fx plus v gx, and these fx can be find out by minus v, and this r is right hand side, or as here r equal to sec x r upon w is Wronskian. This is Wronskian. So this is for fx, and gx can be find out by u r upon w, and we have to integrate with respect to dx as fx and gx. So these fx and gx which are used in this particular integral we can find by this expression. So this is the format how to find particular integral and complementary function for second order linear differential equation when right hand side is not 0. So we proceed this question particularly as y double prime plus y equal to sec x. So value of r equal to sec x. The value of r is sec x, and we can write this differential equation in simplified form as d2 plus 1 y equal to sec x, where capital D is an differential operator can be represented by d over dx. So for this differential equation, auxiliary equation can be written in terms of m by m square plus 1. This is the auxiliary equation, and roots of this auxiliary equation are plus minus iota, means purely imaginary. When roots are purely imaginary, then complementary function can be written as c1 cos x plus c2 sin x. This is the value of coefficient of iota, as the coefficient of iota is 1, so cos x plus c2 sin x, this is complementary function. This is very common. Each student when he study differential equation, he knows or how to write the complementary function. So call this is u and v, as I discussed earlier in this video. What is u and v? So call this is u and v. So w we can find, or Wronskian for u and v. So u, v and their respective derivatives. So u prime and v prime, this is our Wronskian, as u is cos x and this is sin x, and their derivatives are minus sin x, and this derivative of this one is cos x. So this derivative is equal to 1, not equal to 0, as w is not equal to 0. So we can find particular integral by as u fx plus v gy, sorry, gx. And how to find fx and gx? Fx can be easily find out by this expression vr. R is right hand side of the differential equation divided by this Wronskian w and integrate with respect to x. So for this negative of integral, this is v, value of v is sin x, and r was sec x divided by w is 1. So there is no need to write 1. Now this expression can be written as minus integration of sin x upon cos x dx, as a derivative of cos x is negative of sin x is present. So integral of this expression is log of, this is of the type 1 upon x dx type. So log of, and log is always positive, so always defined for positive value, so log of cos x. So this is the value of fx. So fx equal to this log of mod cos x. Now we have to find gx, and gx can be easily find out by this expression ur divided by w and integrate with respect to x. So this is u is in this question is cos x and r is sec x divided by 1 and integrate with respect to x. So cos x upon cos x is 1. So value of this is x. So pi can be written as u fx plus v gx. This is our pi. And general solution is sum of, general solution is cf plus pi. And u was in this question as cos x, and this is fx. We have evaluated log of cos x plus v, and gx is x. So v is sin x, and value of gx is also x. So I can write again clearly log of cos x plus x sin x. This is our particular integral. So general solution or complete solution into I can write yx as, this is ux, and this is was as so c1 cos x plus c2 sin x. This is complementary function and particular integral as we evaluated earlier. So this is cos x and log of cos x plus x sin x. So this is our general solution or complete solution. So on comparing above equation with as given, what is given, ux sin x plus vx cos x is the solution. This is given in the question as yx equal to ux sin x plus vx cos x is the solution. So we have to find the value of cos x. So on comparing, you can see ux is the coefficient of sin x or associated with sin x. So we have to find sin x terms. So this is sin x terms, and this is also sin x terms. So we can write c2 sin x plus x sin x, and remaining terms are, you can understand better. So you can take sin x as a common. So c2 plus x sin x, and when we compare this as this equation, which is the solution, as you can see here ux sin x. So this is our ux, this is our ux. So ux is c2 plus x, means this is of the C2 is a constant, so you can write another constant as C plus X, means this is of the type, so you can understand. So value of Ux is C plus X or X plus C, so option C is correct choice.